Hello everyone. Today we are going to talk about centroid or center of gravity. First, let us see what is the difference between centroid and center of gravity. You can see the definition. It is a point at which whole mass of the body is supposed to be concentrated. Suppose there is a body. This is a plane figure. If you hold a plane figure with your index finger, you will find that there will be one point at which the plane figure will be held with your finger. It won't disbalance. That point is called as the center of gravity or centroid. You can see the definition of center of gravity. It is a point at which whole mass of the body is supposed to be concentrated. You can see both definitions are same. So what is the difference between centroid and center of gravity? It is carried out for plane 2D figures. Centroid is carried out for plane 2D figures. 2D figures like rectangle, right angle, triangle. These are 2D figures, two-dimensional figures. While center of gravity is done for 3D figures. For example, solids. Solids such as a cylinder or a cube. So center of gravity is done for solids and centroid is done for plane 2D figures. So we will be dealing with centroid for 2D figures. This is the basic formula to calculate the centroid. The CG, that is CG is the center of gravity or centroid. CG about x-axis, x bar, a1 x1 plus a2 x2 plus a3 x3 plus it can go till any composite number divided by a1 plus a2 plus a3. Here a1, a2, a3 is the total number of areas of the composite parts or composite areas, which is equal to summation of ai xi upon summation of a. Again, for y bar it will be a1 y1 plus a2 y2 plus a3 y3 plus till n numbers divided by a1 plus a2 plus a3 plus till whatever number of areas are there is equal to summation ai yi upon summation a. Now this sign convention is very important. You can see in the first quadrant x, y both will be plus. X, y both will be plus. In the second quadrant x, y, x will be plus and y will be minus. In the third quadrant x is minus, y minus. In fourth quadrant x minus and y plus. The sign convention is very important. Now, coming to centroid or center of gravity of common figures. You can see this is a square figure having base B. A square will have the same sides. Suppose the sides are B. This is known as the axis of symmetry. Where the point where the axis of symmetry meets is known as the centroid. It is denoted as CG. Now you can see this is the x-axis and this is the y-axis. X bar will always be with respect to the y-axis. You can see this is the x bar. It is always with respect to the y-axis. And y bar will be with respect to the x-axis. This thing you have to keep in mind. X bar will always be with respect to y-axis and y bar will always be with respect to x-axis. So, in this case, the CG will pass through the center of the square. Actually, where does the CG pass through? It will pass where the diagonals will intersect. Diagonal of the square will intersect. That point will be the CG. So I have drawn an axis of symmetry. Now, this x bar will be equal to b by 2 as the base is b. X bar will act at half. So this x bar will be b by 2. and y bar will also be equal to b by 2, and area of the square is b square. Coming to rectangle, this is a rectangle having base b and depth d. Again the CG will pass where both the diagonals will intersect. So CG will be at the center of the rectangle. Now this is the axis of symmetry, which is parallel to x and y axis. X bar is this one and y bar is this one. So x bar will be equal to b by 2 because this is b. It will act at half of b. So x bar will be equal to b by 2 and y bar will be equal to d by 2. So this is the centroid of a rectangle. X bar is b by 2 and y bar is d by 2. And what is the area of a rectangle? It is b into d. Now coming to a triangle. It can be any triangle, not necessarily an isosceles triangle. It can be for matter any triangle. The CG of the triangle will pass through this point. Actually, the CG of a triangle will pass through that point from where the three medians of the triangle will intersect. So suppose this is the point where the medians will intersect. So this triangle is having base b and it is having height h. This is the axis of symmetry. This will be x bar. X bar is always with respect to y axis, and this will be y bar. Y bar is always with respect to x axis. So x bar in this case will be equal to b by 2 and y bar will not be h by 2. It will act at 1/3 from the x-axis. Okay, y bar will act at 1/3 from the x-axis. So it will be h by 3. And the area of triangle will be half base into height. Now coming to a right angle triangle. This is a right angle triangle. Again, CG will act somewhere over here. Suppose this is the point of the CG. This will be the x bar and this will be the y bar. So x bar will act at b by 3 and y bar will act at h by 3 for a right angle triangle. This x bar and y bar will always be from the origin. You can see this is the origin. So x bar will act from the origin and y bar will also act from the origin. You shall not take it from here. If you take it from this side, this will become 2 by 3 b, and if you take it from here, it will become 2 by 3 h. So always you have to remember that x bar and y bar both will be taken from the origin, and the area of the triangle will be half base into height. Now coming to a circle. This is a circle having radius r. If I draw the CG of this circle, the CG will obviously pass through the center of the circle. CG will pass through the center. So this distance will be x bar and this distance will be y bar. So from figure you can see that x bar is equal to the radius itself and y bar is also equal to the radius itself. So x bar is r and y bar is r, and the area of a circle is given as pi r square or pi by 4 d square. Then there is a semicircle. Suppose this figure is a semicircle. Its CG will pass through this axis of symmetry. This will be the CG. This is x bar and this is y bar. X bar is with respect to y axis and y bar is with respect to x axis. So x bar is what? From figure we can see that x bar is equal to the radius of the circle itself. You can see this is the radius of the circle, and y bar will be equal to 4r upon 3 pi. It can also be written as 0.4244 r. So x bar is r and y bar is 4r upon 3 pi, and the area of a semicircle is pi by 2 r square. That can also be written as pi by 8 d square. Now if a semicircle is in this position, so in this case CG will act somewhere here. This is the axis of symmetry. This is x bar and this is y bar. You can see in this case y bar is equal to the radius. Y bar is equal to the radius of the semicircle. So y bar is equal to r. But in this case x bar is equal to 4r upon 3 pi. And the area will be same, pi by 2 r square. So if semicircle position is like this, then x bar is r and y bar is 4r upon 3 pi. And if position is this, then x bar is 4r upon 3 pi and y bar is equal to r. This you have to keep in mind. Now, the last figure is a quarter circle having radius r. Suppose this is the CG from where the axis of symmetry is passing. This will be x bar and this will be y bar. So in this case x bar and y bar both will be equal to 4r upon 3 pi. X bar 4r upon 3 pi and y bar 4r upon 3 pi. And the area of the quarter circle will be denoted as pi by 4 into r square.